Back in the last series in this learning path, I explained how we were creating this domain, company.pri, single domain, single forest, and how the domain and forest, well, the domain company.pri actually has three different sites that are built into it. We have our Denver site, we have our Las Vegas site, and we have our Phoenix site. And the notion here is that we have essentially a distributed network. The Denver site sitting in the 192.168.0 net. The Las Vegas site is sitting in the 192.168.2 net. And the Phoenix site is sitting in the 192.168.3 net. And it's here where we kind of have to assume that the connectivity that exists between these different locations can be different based on essentially what we've paid for. If I think about the connectivity coming out of Denver towards Las Vegas, that could be connectivity. I don't know. What can I afford these days? Perhaps a T1, for example? I don't know. Maybe the connectivity between Denver and Phoenix is something else entirely. Maybe the connectivity between these two locations is nothing more than a DSL line. Maybe between Las Vegas and Phoenix, I don't know. Maybe over here we've got some sort of silly dial up connection. And so the different types of network connections that can exist between these different locations is what's important to consider when you're talking about, first of all, creating the sites, but also creating the different interconnections between. Now, it's here where we have to kind of go backwards in time a little bit. Remember that Active Directory at this point is over a decade old, and is just getting to be quite a bit more mature than it was when it first came out. Think back to the early days of Active Directory and what was going on in that turn of the last century days when we were trying to connect together sites in different locations. Being able to have a multi-megabit connection between locations was something that was probably very expensive at the time. Not a lot of organizations could accomplish that. And so the sheer traffic that had to occur in order to get Active Directory content replicated from one location to the other could be a significant portion of the total traffic that exists, or the total potential for traffic that exists between those two locations. And it's because of this that when we're configuring our Active Directory, we needed to configure it in some way to assure that the amount of available traffic that we had was in no, or bandwidth that we had, was in no way going to get in the way of all the other communication that had to occur between the different sites. And so because of that, Microsoft introduced mechanism here with sites and subnets to be able to control when replications would occur. Replications inside of a site, so here inside of the Denver site, would occur relatively quickly, right? Maybe just a couple of seconds or a couple of minutes when I was making changes to content that exists inside that Active Directory site. Domain controllers in Denver are together in the same local area network, and so the cost of transmitting that information from one domain controller to the other, from one switch on a port to the very next switch on the port, was relatively low. Contrast this with the amount of cost in terms of network bandwidth, and then the cost for that network bandwidth to get the same amount of traffic back to Las Vegas or back to Phoenix. Back in the old days, that could be something that was relatively expensive. And so when you think about sites and services, you have to take kind of the long view of how these configurations were set up. In that, these days, perhaps it's not really terrifically important for us to tailor things down, except if we're in an environment that can be extremely large with lots of replication traffic. For most of us, we've probably got enough network connectivity that exists between our different locations to support the very relatively these days small amount of traffic that could fill that potential pipe. Now, because of this, you're going to see a lot of options in there, a lot of configurations that in the real world, in an actual production world, you may never really need to modify all that much. But again, many of these configurations were there because they're artifacts of a time gone past. Now, sites and subnets also provide you the way of figuring out exactly how communication should get routed around a very large network. In our network here of 3 different sites, it's kind of difficult for us to really see how things would be routed around. I mean, for traffic to get from Denver to either of the 2 locations involves, well, 1 hop. And for it to even involve 2 hops, say for example from Denver to Las Vegas, and then from Las Vegas over to Phoenix, for it to involve that 2 hops means that my connectivity between Denver and Phoenix has to be less than the sum total of the 2 hops together, right? So it's very difficult for us to understand in a 3-site circumstance why this actually makes sense. But let's actually expand this whole concept out into a much larger and potentially continent-wide configuration. Let's say we have an environment not just of 3 sites, but instead we have an environment of multiple sites. I've got my main site here in Denver. Right here in Denver is where the biggest data center is and where the largest number of people is. And I've got the other two sites that we've been working with as well, with Las Vegas and Phoenix. And I've probably got some reasonable traffic that may be going on between Denver and those two locations. So configuring just using the defaults for that traffic may be something that I might want to do. But as the number of potential sites, or the number of sites, begins to get large, you can see where the changes in the site costs that we will later be configuring can have an impact on how data gets transferred, how replication data could get transferred around a very large network. Let's assume that over a period of time, our organization adds additional sites in Boston and Miami and in Chicago, in San Francisco. And so all of these additional sites are now connected together with Denver, Las Vegas, and Phoenix, and we now have the need to be able to route traffic between them. This does perhaps a much better job than our little 3-site example of helping you understand why I might need to be a little more careful in a very large network about how traffic gets sent around the network. Right, I've got site link connections that I'll be connecting here between Denver and Las Vegas and Denver and Phoenix. I might connect up a connection as well between Las Vegas and San Francisco, but does it make sense for me to make that connection? Or perhaps is the connection from Denver to San Francisco directly a better connection? Is the bandwidth directly from Denver to San Francisco greater than the amount of time it takes to hop from Denver to Las Vegas and then from Las Vegas to San Francisco? How do I then want to set up the other connections to my environment? Do I take Denver and connect it up here to Chicago, for example, for another site connection? Does Chicago then connect with Miami down here? Does Miami connect with Boston? Does Boston connect with Denver, or does it make more sense for Boston to connect directly to Chicago? These connections in a much larger network begin to provide a little more color as to why sites and services can make more sense in a much larger network. Being able to figure out exactly where the areas of high network traffic are as opposed to those of low network traffic will help us determine what kinds of sites, subnets, and then site links need to be created so that my replication traffic most appropriately gets connected throughout the environment. One other thing that we'll be talking about a little later has to do with Microsoft's or Active Directory's knowledge consistency checker. When you go about creating all these interconnections between these locations, it's the job of Active Directory itself and the KCC, the Knowledge Consistency Checker, to, with the structure that you've put in place, then determine what the best topology for getting my information transferred around the network in the most efficient way possible. That is really a complex problem, and it's something that the KCC has been evolved over the years in order to best accomplish depending on what these different interconnections are.